Hey, welcome back. Today on my bench I have a NAD power stereo amp. It's a 2140 power amp. There's nothing more to it. I picked these up. Actually, I picked up a pair of these. Not a pair of these, but a pair of NAD amplifiers listed on the local Kijiji, and they were good price. The guy that listed them said that they worked. He put them in storage. He brought them out of storage. They didn't work. The typical story, you know. So he just wanted to get rid of them. So I took them off his hands for a decent price, and we're gonna get them back to 100%, and then hopefully find him a new owner. So I've never worked on NAD before, and I was really surprised at some of the quality of these units. Removable bottoms. They have the inspection sticker still on them. The front is pretty sparse. It's got 3 indicator LEDs, power, SLC, and soft clipping. And then it's got 2 speaker outputs, which I find is odd because they have speaker B listed first and then speaker A. I wonder what the reasoning is behind that. I don't know. And then a power switch and a phone output. The bloody thing is heavy. I'll show you why in a minute. Wow. Okay, so it's got a couple of courtesy outlets, 2 speaker outlets, and 2 inputs. One is a normal in and one is a lab in. And from my understanding, the lab in is totally a straight line into the amplifier without any input compensation or filtering. The normal in has some low cutoff and high cutoff filters on the inputs, so it kind of keeps it into the audio spectrum. And then we have a bridging switch, which is missing a cover. I don't have a cover for that, so I might have to make something. SLC switch, which stands for, I believe, speaker lead compensation. So if you're using a long set of speaker wires or a thin gauge, you would hit that and it would provide a boost or something, I guess, I don't know, for the output. We'll have to look at the circuitry before we wrap this up. And it's got a soft clipping button. Don't ask me what that does. Now, since the guy said it didn't work, I'm just going to check the fuse here. And the fuse is good. So I'll put it back together. Let's pull the top off, have a look inside. Alright, the big reveal. Looks like we might have a little bit of liquid damage here. A little bit of liquid looks like was spilled in. And that would be over top this transformer. You can see a little bit of corrosion going on here. Oh, it looks good. Everything's... What the hell was that? More quality control. Wow. Bunch of fuses here, they all look intact. There's 2 fuses down here look intact. So I'm guessing everything's working. We are going to power this thing up. Now let's power this up and see what we can do with getting a signal out of it. So the reason it weighs so much is it has 2 power transformers on the left side of the chassis. You know, that's also good because this you can put into bridging mode, this amplifier, and we'll play around with that too. But for right now, I want to check to see if there is any DC voltage on the outputs. So I'm just going to measure You can see that? Probably not. Probably can. Okay, I'll turn this on. The power light. And we have speaker A on, so I'm going to check on speaker A. I think this is speaker A. No, that's speaker B. Let's turn this off, turn that on. I don't know why it's all backwards. So here we have 520 500 millivolts and dropping. Here I got 180 millivolts and steady. And dropping maybe a little. This concerns me, this half a volt here. It's 450 now, 445. Might have to look into that. So, turn that off. Let's connect the speakers. Turn the power and the speakers back on. You can hear there's a DC component when you click the speaker switch. That's not good. Anyways, signal generator, let's turn up the volume. Both channels are working. My little bench speakers probably won't be able to handle this. Hey, well, we know it's working. Let's put it on, turn off the speakers, turn on the dummy load. And let's get this on the scope and see what we can do. Okay, we're back. And we have a scope on. You should be able to see it up in your corner. Let's turn this back up. Let's turn it to a... Let's turn this to 1 kilohertz. Okay, so I'm just going to keep increasing the input until we get clipping. Right about there. These transformers are very noisy. Which tells me we may not have enough. If the audio is getting through back to the transformer, that power supply filter caps aren't doing their job. So let's see, we're at clipping here, and I got 26 volts even RMS output on 8 ohms. Both channels seem to be doing exactly the same thing. Although one of them's out of phase. So I guess the bridging button needs to be pressed. It's out right now. I'll shut this off. Let's hit the bridging button. Try this again. See, now they're both in phase. Clipping right there. 26.3 volts RMS output. Seems to be doing well. Just let this roast for a while. What I'm going to do is I'm going to turn the frequency down to 30 hertz. There's a little bit of distortion on the top of the waveform. .3 volts RMS. Turn this up to 60. Okay, I'm playing around with these switches in the back. I'm not touching the bridging while I got it under load, but the speaker lead compensation, I'll turn that on. You can see the effect it has on the scope going right now. It drives it into clipping. So if I turn the amplitude down a little bit, quite a bit, that puts me at right now 25.7 volts RMS. I'll turn it off, and then you can see it drops to 21.85 volts RMS. So it looks like it's cutting back a little bit on the power. When I push it in, it's boosting the power to the amplifier. And the soft clipping one, here, all going on now, does nothing. Okay, well, let's turn this up a little bit. Okay, so I'm right at the verge of clipping there. Turning on the soft clipping drops the output a bit. So without the soft clipping, I'm at 25.85 volts RMS. Turn it on, and it drops to 25.1 volts RMS. Has a little effect on the let's turn it up a little more to clipping, hard clipping. See if I turn it down, it has a little bit of effect on the clipping. Okay, I've gone through the amp and I've replaced let's see here, 10 caps, I think. Looking at this, some of these caps, the 10 microfarad 35 volts, they were in the circuit here and they were getting roasted by some resistors, so I replaced them. There was a couple of 47 microfarad caps back in this corner that were bad, or not bad, but they were just, you know, over the limit, and if I would have left them alone they would have been bad. And then I changed out 4 of these 1 microfarad 25 volts Sanyo caps. They're in the input circuits. I replaced them with metal film capacitors so that they're more stable and reliable. So we won't have to worry about those ever again in the future. So I have everything done. Ready to do a test. One final test I want to do is in bridge mode. I want to fire this thing up and see what its maximum output is in bridge mode. So let's do that now. Get powered, and I think I am on speaker B. Speaker B, and I'm on the scope. Let's start feeding it a signal. Turn on the signal generator, and I have it hooked up to an 8 ohm load so we can monitor the output. Let's keep turning this thing up till we get some clipping. Right there. So, in bridge mode we have 43.6 volts RMS output. That's a 1 kilohertz tone. And let's let that cook for a while. See, when I turn on the SLC, it jumps quite a bit. If I turn it off, my power drops to 37.2 volts RMS. But with it on, it gives it a considerable boost. You can hear that 1000 hertz whine coming out of the transformers or somewhere here. So, seems to be doing good. Shut this down. One final thing I need to do, and I forgot to do that before I did this test, is I have to tweak these pots, the idle current and the DC offset. And I remember at the beginning I measured some offset on the outputs. We're going to see if we can deal with that. Alright, so I finished with the alignment of the amplifier, the idle current, and the DC offset. So those are both bang on right now. I had about 500 millivolts on the one channel before, but now it's down to nearly 0. And everything's good. Looks like I'm done. I'm going to wrap this up, and I think what I'm going to do is I'm going to list this for sale. One thing that concerns me though is you turn the power off and the LEDs stay on forever. It's like the capacitors are charged inside and they don't go off. But you would think that they would have a circuit in there to maybe kill that. I don't know. It's confusing. You got your power shut off and the lights are still on. Wow. Anyways, that's it for this. Thanks for watching, and hope to see you again.